Good morning. Good morning. How you all doing today? So we're going to go on to the next thing, which really isn't that much more complicated than what we did the other day. So just like the opposite of addition is subtraction, the opposite of multiplication is division. Since the last time we were doing the product of powers, today we're going to do the quotients of powers. So it's just, instead of dealing with multiplication, we're going to be dealing with division. So products of powers is multiplying and adding. Well, that's none of my business. What? So all I have to do on a product of a power is multiply the numbers and add the exponents with the same base? Yes. So today, just like the opposite of addition is subtraction, the opposite of multiplication is division, today we're going to be doing the exact opposite of what we did the other day. So what happens if you divide powers? So let's look at the first question. And it says 4 to the 5th divided by 4 squared. What is 4 to the 5th divided by 4 squared? So it's 4 times 4 times 4 times 4 times 4 divided by 4 times 4. So if we were to just break this up, decompose it, you guys did this in 4th and 5th grade, where you're just breaking a fraction up into parts. Since everything here is being multiplied, I can separate it however I need to, as long as the 4's in the numerator are still in the numerator and denominator ones are still in the denominator. So I could take this equation and turn it into this. If I take these two up top, these two 4's and these two 4's on the bottom, make that one equation, I can split these two up. Because if I multiply this times this, I will get that. So these two are equivalent. All right, well, what happens if I were to go ahead and simplify this right here? This is 4 to the 3rd. This is 1. Okay, because numerator divided by the denominator, if they're the same, with two exceptions, then it will always equal 1. So 4 to the 3rd times 1 comes out to be 4 to the 3rd. Well, how do we get there in a much faster way? Okay, so starting here, sometimes what you'll see teachers do, your parents might do this if you have an older brother or sister who are doing this, you might just see them cross out. Okay, for every factor in the numerator, you can cross out a factor in the denominator. Why does that work? Well, it's really this. Okay, you're not really getting rid of it. What you're doing is you're just pulling those factors out. And when you have a numerator and denominator of the same factor, it always counts, it makes it equal to 1. And anything times 1 is itself. So anyway, let's use what we did last time. If you remember when we multiplied, what we did is when we multiplied powers with the same base, we added the exponents. Well, we're dividing. Division is the opposite of multiplication. So whereas last time we added the exponents, today we're going to subtract them. Okay, because what you're doing is you're really crossing out, or you're removing. Think about it. How many 4's did I remove over here? The numerator, I had 5 of them. Well, I removed 2 of them, didn't I? So we're really just subtracting the exponents. Now this is your trick. It is the algorithm as opposed to why it actually happens, which is what I showed you on the previous slide. So 5 minus 2 is 3, so this is 4 cubed, just like we got on the other slide. So there is an actual algorithm for it. Again, we're coming back to that variable a. So a to the m, so a, any number or any variable, and actually it could be like a 2x or a 5g or whatever it was. You could have that here too. We're not going to go that far today, but it is possible to have that. So anything raised to the power, okay, divided by anything raised to a different power, it could be the same power, but the same base, okay, a to the m divided by a to the n is a to the m minus n. Now there has to be a caveat in here where a can equal 0, because you guys know that you cannot divide by 0. Anything divided by 0 is undefined. So as long as a isn't 0, a to the m divided by a to the n is always going to be a to the m minus n. So let's put that into practice. 2 to the 6th over 2 to the 4th. Okay, so that becomes, we just subtract the exponents, so that would be 2 to the 6 minus 4, or 2 squared. Now we can have negatives in there, not that big of a deal. So negative 7 to the 9th divided by negative 7 cubed. All right, so we're just going to subtract. So it's the base and then you're subtracting the exponents. 9 minus 3 is 6, so negative 7 to the 6th power. Now today we're writing everything in as a power. We're not simplifying anything beyond this. Does it always have to be numbers? No. It can be exponents. So h to the 7 divided by h to the 6th. So that's h to the 7 minus 6, or h to the first. Now, we do not write an exponent of 1. It's understood if we don't write an exponent, it is 1. So we would simplify it. Even in power form or exponent form, you would just write it like this. Now, you don't always have to have a specific integer or a variable. You can have kind of a weird number in there. So 4.2. Again, nothing different here. You take the base, subtract your exponents. Okay, now we can't have an exponent of, well, we can have an exponent of 1. We just don't leave it like that. And we just write it like that. Now, some of you might be thinking, what happens if you have the power in the denominator, the exponent denominator is larger than the numerator? We're going to cover that next class. So let's switch it up a little bit. Sometimes you can have operations in the numerator or in the denominator. That's totally fine. So something that looks like this: 6 to the 7th times 6 cubed divided by 6 to the 5th. Right, well, you just do the part in the numerator first here. So 6 to the 7th times 6 cubed is 6 to the 10th. Now, once you're in this part, you're doing what you did before. You have the same base, subtract your exponents, comes out to be 6 to the 5th. So now let's take a look at this one. So you're having two different equations here. You can do cross-canceling. I'm not going to do cross-canceling with you because that's not really what this lesson is about. But what we're going to do is solve each part of the product individually. So this is one factor, this is another factor, and then we'll find the product of those two. So this first one is negative 4 to the n minus 5, and this is negative 4 to the 8 minus 2. Well, we solve those. That's negative 4 to the 4th times negative 4 to the 6th. Well, that just becomes negative 4 to the 10th. Not overly complicated. All right, the final one. P cubed times p to the 6th over p squared times p to the 4th over p. Woof! First thing we're going to do is simplify the numerator here. So p to the 9th over p squared times p to the 4th over p. Now we're going to solve each factor individually. So this is p to the 9 minus 2. This is p to the 4 minus 1. So that's p to the 7th times p cubed, which is p to the 10th. Okay. Good luck today. If you have any questions, please reach out. Have a good day. Stay safe and healthy. Bye.